The first video on trig equations introduced this diagram. It gave related angles in each of 4 quadrants. So the first quadrant was between 0 and 90 degrees, second one from 90 to 180, third one from 180 to 270, and the fourth one from 270 to 360. So we're turning anti-clockwise. This is an acute angle. If you, for example, had 30 degrees here, this angle 180 minus 30, 180 plus 30, and 360 minus 30. These 4 angles, if you were to say get the sine of 30, sine of 150, sine of 210, and sine of 330, they would have the same values. So here, sine 30 is a half, sine 150 is a half, sine 210 is a half, sine 330 is a half. But 2 of them are positive a half and 2 of them are negative a half. And this ASTC tells you whether the functions are positive in value. So all are positive. Only the sine is positive. Only the tangent's positive. Only the cosine's positive. So there are 4 quadrants, and this tells you where functions go positive, and when they're not positive, they're negative. So for example here, sine 150 is also positive a half. Sine 30 and sine 150 are the same. This says sine only is positive. This is sine 150, so it's positive. Whereas here, for sine 210, you're in a quadrant where it says t. That means only the tangent's positive. So we're dealing with the sine of an angle. It's a negative. Same here for sine 330. It says cosine only positive. Well, a sine is then negative. So twice it was positive, twice it was negative. We're dealing with sine of an angle. This is telling you where the sine's positive at A and S, and therefore it's negative in the other 2. Now, we use this to solve trig equations. Suppose you're asked to solve sine x equals a half, so it's a positive a half. All you do is you look at the quadrants here and you pick out the 2 that came with positive a half, here 30 and 150, and you write the answers. You just pick them out. If it said sine x equals negative a half, you pick the 2 that were given the negative answers, 210 and 330. So you're just picking them out of this arrangement. It doesn't really matter how you solve this trig equation as long as you get the 2 answers. Strictly speaking, it's x equals 30 or 150, but we're just going to write them with a comma between them. Now, same procedure. If it was cos 30, then cos 150, cos 210 and cos 330 come up with the same value, except 2 of these values out of the 4 are positive and 2 are negative. So always everything's positive in the first quadrant here. So cos 30 is root 3 over 2. They're all root 3 over 2. But if you notice here, second quadrant is negative root 3 over 2 because sine's positive and this is a cosine. Same here, cos 210 is negative because only the tangent's positive in this quadrant. Whereas here when it says C, that means the cosine's positive, and it's a cosine. So again, if you're asked to solve cos x equals positive root 3 over 2, you pick out the one where it's A and where it's C. That's where the cosine's positive, A and C. So you're after a positive root 3 over 2. A and C is where the cosine's positive. It's these 2. So that's 30 and 330. Whereas if it said cos x equals negative root 3 over 2, it's not the A and the C, it's the other 2. So that's 150 and 210. So positive for the cosine, you pick out the ones that says A and C. Negative for the cosine, you pick out the 2 it's not A and C. Similar for the tangent. You want tangent 30, it's 1 over root 3. If you look at the others, they should all be 1 over root 3, but out the 4, 2 are positive, 2 are negative. So there they are there. Tangent, it's in the quadrant where it says sine's positive, so I'll get negative 1 over root 3. Whereas here, tangent 210, it says t in this quadrant, tangent's positive, so we'll get the same as A here. A and T is where the tangent's positive, and 330 here, you can see it's negative, it's in the wrong quadrant. So if you're asked to solve that equation, tan x is positive 1 over root 3, pick the A and the T quadrants, 30 and 210. if it had said tan x equals negative 1 over root 3, pick the quadrants where it's not A and T. In other words, the other two, 150 and 330 for the angles. So it's just using this to pick out the correct answers. Some people use the graphs to get the answers. It doesn't matter how you get them. So, solving trig equations is really about using this diagram, with the exception if sine x or cos x are going to equal 0 or 1 or negative 1. We don't use this because it doesn't work well. It actually puts you on the lines there. It's not useful. You should know these graphs from when we transformed trig graphs in a series of videos. So by knowing these, you know where sine becomes 1, it's at 90 degrees, or negative 1 at 270, or where it's 0 at these three positions. There'll be examples in these at the end. So, how to solve the trig equations? First, it's over an interval between 0 and 360. So it might say that. That just says x lies between 0 and 360, inclusive. That is, includes 0 and includes 360. So sine x equals 0.5. First, you've got a little diagram. Next, you want to say, what is A? What's this acute angle A? Because when I get it, I can work the elements out. So you want to get that acute angle. You inverse sine 0.5 in the calculator, it comes up 30, but you should know sine 30 is a half by now. Next, you say it's positive. That's where it says A and S. That's where all positive and sine's positive. So you want 30 and you want 180 minus 30. In other words, in your angles, we're dealing with 30, 150, 210, 330, and it was in these two quadrants. Your answers are the 30 and the 150. That's what you need for an answer. This is just working out the road. However, the initial equation might not have said just simply sine x equals 0.5. They could do this. Could say 2 sine x minus 1 equals 0. Solve it. Well, what you do is you isolate the sine x. This says minus 1. Add 1 to the other side. This says 2 sine x equals 1. Divide by 2. Sine x is a half. So you've got a mark for solving this to this stage, sine x equals, and then you get the two answers, however you get them. So 3 things to do. 1, get it down to sine x equals 0.5, and then secondly, get these two angles. Now, mostly you'll be working with the calculator. I've used the exact values here just for convenience. Suppose you'd been solving sine x equals negative 0.5. You do exactly what we just did there. You just pick out the two where it's not A and S, which is 210 and 330. So when it comes to the angles, you're picking them out of this diagram. There's 4 interrelated angles. You have to pick the right two. If it was a calculator paper, you can put them in the sine 30 in the calculator and sine 150 and see if it comes up positive a half, and correct it if it's not. So here's a similar one. This is just 2 cos x minus 1 equals 0. So you isolate the cos x. Now you're going to solve this. You've got your diagram. You have to decide its cosine, it's positive. Get the two correct quadrants where it says A and C. That's where cosine is positive. And find out what the angle should be. That's A in the first quadrant, because then you can get the other angles. So you inverse sine 0.5, and you'll it's really another one you should know, which is 60. So cos 60 is a half. Just like sine 30 was a half, cos 60 is a half. And you've picked out A and C. There's the angles. 60, 180 minus 60, 180 plus 60, 360 minus 60. It's in A and C, so it's the 60 and the 300. So this is the bit you went down for the answers. This is working out at the side. Now, if you were solving cos x with negative 0.5, you're just picking out the two where it's not A and C. That's the 120 and 240. So it's positive in these two, you just pick out the other two. It's maybe worth mentioning that even when you're solving this says cos x equals negative 0.5. You still inverse cos positive 0.5 to get the first quadrant angle, 60. If you did inverse cos negative 0.5 on the calculator, it might give you one of your answers. But back here, if you'd inverse sine negative 0.5, the calculator would give you negative 30, but you don't want negative 30, you want this positive 30. You want an angle between 0 and 90. So if you inverse sine negative 0.5, you'll get negative 30, and it's not one of your answers. Here in the calculator, if you inverse cos negative 0.5, you will get one of your answers. You'll get one of these two. You'll get the 120, but you won't get the 240. And it's not easy to go in from the 120 to get the 240. So try to remember not to inverse cos or inverse sine or inverse tan a negative when you're doing trig equations. You can on other occasions with the triangle formulae, but not for this. There's a tangent question. You've got your arrangement, you need to solve it. So here we go. There's the equation. That plus 1, you take 1 away from the left, you take 1 away from the right. Or if you like, it's plus 1 here, you minus 1 on the other side. Now you divide by 3. This is a tangent and it equals a negative. So you have got to decide what quadrant is the tangent negative. So where's it positive? A and T. So it's the other two. The other thing is don't inverse tan negative a third. Inverse tan positive a third. So there's the two quadrants where it's not A and T. And inverse tan positive 1/3, not negative a third, because you want the acute angle in here first, and then you can work the others out. Now, it's 180 minus that angle, and 360 minus that angle. So rather than fill them all in, all I'm going to do is 180 minus this 18.4, using it unrounded, and this 360 minus, and that's the two answers. And you just write them down. So up to here we've been using exact angles, and it's quite easy to write the four of them in. But really all you're doing is finding out where the tangent's negative at these two quadrants, inverse tan the positive a third to get the acute angle in the first quadrant, and replace A, 180 minus that angle, and 360 minus that angle. Now all this at the side won't get you any marks. It's this writing them. It's getting tan x equals negative a third and getting these two answers, however you get them. So that's solving trig equations. Here's the exceptions. 2 sine x plus 3 equals 1. Subtract 3 from each side. Divide both sides by 2. When sine or cosine are 1, negative 1 or 0, think about the graphs instead. When does sine of an angle become negative 1? At 270 degrees, and you just fill it in. So you don't use it for sine or cosine. You don't use the all sine tan cos for sine or cosine being 1, negative 1 or 0. You think about the graphs. 3 sine x equals 0. Well, sine x is 0. When does sine of an angle become 0? At 0, 180 and 360. So there's three answers. And that's with interval matters. See how this says with this bar and an equality sign, it means it includes 0 and it includes 360. So the two of them are there. Sometimes there might be a bar missing from one of them, and it's only one of these. It might exclude, it might just be a less than sign with no bar on it. You've got to watch whether it includes the 0 and the 360 or not, and it does in this case. Here's another one. This is just with cosine. So it's the same thing. Isolate the cos x. Think about the graph. When does the cosine graph become negative 1? 180 degrees, and write the answer in. Oops, easy. So that's the using the graphs. And again, it's these key points. If you click the link in the download, it'll give you access to worksheets. So this worksheet will have the answers with it. The answers are on it. So you'll have the worksheet and the answers, which you can get from the link in the description. So it's just lots of practice. The first lot are just straightforward, sine x equals cos x equals, and here you've got to solve for sine x equals first and then solve the trig equation. Calculators will be needed. Answers, you can see, need round to 1 decimal place. So using the link in the description, you can get the worksheet, and it'll have the answers, and there's a set of notes which has got all the things for the trig equations videos. So there are notes there. The next video is on trig identities. Hope you found this video useful.